All right, so a couple things off the top. My emails are a little backlogged, so if you send me an email Friday, I'll be working through those this afternoon, or if you send me an email earlier today. I also wanted to mention two things that are due at the end of the week. The first is that first homework. The second one is kind of your project proposal. So I've had a couple of you reach out to me. Even if you talk to me or reach out to me via email, I still need you to upload something into that project proposal. I've got a couple of data sets already out, so quicker those come in, the quicker I can get data back out to all of you. If you have any questions or if you're in between ideas, and then feel free to reach out. I'll be in my office 2 to 4 today, Wednesday and Thursday. I'm around the building most of the time on Thursday on Tuesday and pretty free. So if there's a time slot that works for you, shoot me an email. We can try to set up an alternative time. Okay. Any other questions for me before we jump into this? Okay, so I actually made my mind up earlier this week about which paper I wanted to go over. So that should be, I kind of labeled it as week 4 reading, right? So this is about player contracts in the performance of players in years surrounding when they're signing new contracts. I also put up lectures. There's going to be some significant stuff missing in terms of what we're going to be doing on the board. So anything I do on the board, I would highly suggest kind of taking notes on. Okay. That being said, we'll kind of dive into it here. So a couple slides I skipped last week and wanted to make sure we had enough time to kind of go through these. Might be a little bit more, I guess, complicated than some stuff you've seen before. Is this idea of league-wide advertising, right? So the league has a general interest in, not promoting one specific team, but promoting the league as a whole, right? You could even break this down into, I watched a little football yesterday. It's not just the NFL, it's things like the USFL, right? They're putting out league-wide promotions, every other commercial during football games for that. And this league-wide advertising, we can think of it as something you've talked about in other econ classes, which would be a public good, right? Because once the league pays for this advertising, every team gets to enjoy it, right? It's, in that sense, it's non-excludable, right? It's also non-rival in the sense that just because I'm enjoying it doesn't kind of detract from the marginal benefit of other teams, right? So we've got a really good example of a public good. So we recall maybe from 201 or other classes, what generally occurs with the optimal quantity that the free market will choose of a public good relative to what will be optimal for society. Generally, if we allow the market to operate freely, the quantity chosen of a public good is too high or too low. Too high. So generally, we would actually want it to be even higher, right? So if you think about a public good like, with most public goods, the government steps in, right? But the idea of a public good is that, well, once it's built, right? Once, for instance, somebody spends money, like this is some ultra billionaire, and he spends money on military defense for the US. Well, we all get to benefit from it, right? It's non-exclusive. Once he's paying for it, like we all benefit from that military power, right? It's also non-exclusionary in that we can all derive benefit from it at the same time. The problem is no one person benefits enough to probably solely fund the military. So that's why we need another body, which is the government, to take a little bit from everyone to build this, right? So if we have the league making this optimal kind of league-wide decisions, generally what we're going to get is we don't get enough ads, right? So we can kind of break this down, take a look at this with some numerical values. We'll be doing a lot more with equations today. I mean, kind of focus math heavy today, although everything will be kind of kept linear. So each team is going to benefit from this league-wide promotion. Now, if we could do this optimally, right? Just like everybody marginally benefits from having military defense, if we could figure out how much each person benefited and charge them exactly that amount, we could then get the optimal level of military defense. Just like if the league could figure out how much each team marginally benefits from each ad, charge them that exact amount, we could get the socially optimal number of advertisements for the league, right? So the free rider problem exists, however, in that if I'm not able to figure out what these exact marginal benefits are, well, then anybody who benefits a lot might be willing to pay for these advertisements, but that's going to benefit everybody else who doesn't pay. So if I'm a small market team and I'm like, look, I already know that New York and LA teams, They're going to put out advertisements for their games. You know, it's going to happen to be games that are against me. Some of the times I'll enjoy that benefit and they're going to have to pay for it all. And I keep my costs at zero, right? That's the idea of the free rider problem. People who don't benefit as much, they can kind of free ride off of the people who benefit more, paying for that public good. Okay? So I'll come back to this. We can think about this. Let's see an example of this. Okay? So let's say I've got 15 small market teams, 15 large market teams, just keeping it two groups just to make it simple for right now. So the intercept for the small market teams is 10,000. The intercept for the large market teams is 20,000. And each ad, you can think about it as, I believe I had, each ad costs, maybe it's my next bullet point, right? Each kind of league-wide ad costs $150,000, okay? So I can start to build this out and think about what the optimal level for the quantity of ads is going to be. Now, if I just think about any one firm's demand curve, I would say, let's even just do large market, right? I said that, well, for the large market, any one team, their demand curve for advertisements, right? The number of ads they want to run for their games or promotion would start at 15,000. And then if we have the slope here, I'm thinking I probably wanted this to be decreases by 1,000. So we've got our demand curve looking something like this, right? Well, if each ad costs $150,000, what's the optimal number of ads for any one team to purchase? Well, where would my marginal cost be? Even if I keep it constant at 150,000, where does my marginal revenue hit my marginal cost? Well, it would actually be somewhere back here at negative, right? So we would end up with this optimal quantity of ads for any one team. Every team's going to decide, I'm not going to pay to run some league-wide ad, right? Run ads for my game because it's not valuable enough to me. Now, once I run an ad and it benefits every other team, well, now you take the marginal benefit and not just of one team, but it's of all 30, right? So if we want the league to kind of be our government, our organizing body that makes a more socially optimal decision, what we're going to do is say, okay, we know what each team's demand curve looks like, right? So the small market teams started at 10,000, had a slope of negative 1,000. Large market teams had 15,000, slope of negative 1,000. So how can we get a league-wide demand for advertisement? Okay. So I'm going to erase this here real quick and think about, okay, we know that if we allow this, the teams to freely operate, nobody's going to choose to promote the league as a whole. No one's going to purchase these league-wide ads, right? Well, what would be optimal for the whole league or society? We can think about, well, what would the intercept be, right? Well, we've got 15 teams with an intercept of 10,000. So the idea of a market demand curve is we just add up everyone's individual demand curve. So you would have what? 10,000 minus 1,000 Q times 15. That would represent the demand that would be coming from small market teams. You would then take, I might have written it up there wrong. It wasn't 15,000. It was 20,000 for the large market teams minus 1,000 Q. Multiply that by 15 because there's 15 large market teams. Once I add all those together, I guess I didn't put this in the bullet. Let's see how I do this math in my head. So, right, 15 times 10,000, 150,000, 15 times 20,000. It's going to give me 30. So 30 plus 15. So if I'm doing the math in my head correct here, 450,000. Right. So that was just what my intercept is going to be, right? Take 15 times 10,000. There was 15 small market teams. Add to that 15 times 20,000 because that was the intercept for large market teams. For every ad I run, it's going to kind of cost each team, right? Could bear this burden of $1,000, right? So if I've got, what do you think about this? So I've got what, 30 teams times 1,000. So 30,000 Q, right? It's clear how I'm coming up with those. I'm skipping a couple of the steps here. I'm saying it verbally, but right. I had these two representative demand curves. I had 15 teams of each type. So I took those representative demand curves, multiplied each one by 15, and then add them together, right? So 15 times 10,000, 15 times 20,000 gave me the intercept of 450. 15 times 1,000, 15 times 1,000, add those up, that gave me that slope of negative 30,000. Okay with that? Any questions? So I now have my new demand curve, which I know starts at 450,000. That's my intercept. And then it decreases by 30,000 for every additional ad I want to run. All right. So let's see if I can do this math in my head. So it'd be what? 150? No, 15 is where it would kind of hit the x-axis, right? Am I doing that in my head correct? I think so. Tell me if I'm not. But I think if you divide 450,000 by 30,000, right, we should get 15 then. So I know where it starts. I know where it stops. Well, the optimal quantity is going to be where this demand curve kind of hits my marginal cost, because here my marginal cost, if it's for the entire league, it's like a monopoly. It's my entire supply curve, right? So we can just think about if I have this nice constant marginal cost, which was what, $150,000 per ad. I can think about how do I find the socially optimal quantity of number of ads for the league? It's simply going to be where this marginal cost hits my demand curve. So I know this is the quantity I want. I can kind of call this, socially optimal, or for the league, what would be socially optimal? How can I find that quantity?
Set it equal to that 150,000.
Yeah, I've got kind of this marginal cost that's constant. Well, that makes my life a little bit easier because now I know my marginal cost is always 150,000. So I set my marginal cost equal to this equation I had that represented my demand curve, and that's just a little bit of math, right? So I get 450,000, right at this, and I set that 450,000 minus 30,000 Q equal to my marginal cost. Demand is setting equal to marginal cost, and then I just have to solve. So subtract 150 from both sides. I've got what? 300,000 on one side, add the 30 to the other side. 30,000 Q over here. Divide both sides by 30,000. And I get that my optimal quantity should be set for the league at 10. So this was like a very extreme example that if I allowed it to make individual teams to make the decision, I will end up with zero. As we were starting out, no one's individual demand curve was near high enough to buy this good. However, the league as a whole, if we could all come together and chip in our money, well, the optimal level for the league should be 10, right? So unless we have some organized governing body, right, the league, just like we have the government in more general situations, we're going to end up with a number of ads that's way below that socially optimal quantity. Okay. And it, kind of kept this simple. We had this constant marginal cost. And instead of having to set like our supply equal to our demand equation, our supply equation was basically just whatever that value was, that constant marginal cost of 150,000. Okay. Any questions on this idea? I also might expect you know how to do this in terms of if I've got a representative demand curve, how can I turn individual demand curves into market demand? Well, if I've got 15 teams, each with this as their demand curve, it's take that demand equation, multiply by however many teams it's representing. In this case, 15 of each. Questions before we keep moving here? So I kind of mentioned the previous slide, right? One issue is, well, once I pay for these ads of the league, I know for a fact, so let's say, oh, actually, I've got it. No, I'll keep that here. Let's say I've got my large market teams. I know how much their marginal benefit is going to be because if I plug 10 units into here, I can figure out what their marginal benefit is, right? So if I plug a 10 into here, I've got what? 10,000 kind of being the marginal benefit for those large market teams. If I'm doing the math in my head correct, right? 10 times 1,000 is 10,000, 20,000 minus 10,000 is 10,000. That's their marginal benefit for that 10th ad. What about for the small market team? Well, 10 ads times 1,000 is 10,000. Their marginal benefit of the last ad is actually zero, right? So these larger market teams are going to be benefiting more from this league-wide advertisement, right? So if you're being fair and you're trying not to widen that competitive balance gap, right? What you would want to do is somehow try to mandate that teams pay in to this central, amount that's going towards league-wide ads, a proportion of their overall revenue, right? Or, somehow trying to identify these large versus small market teams. Now, this isn't going to strictly be based off population. It's likely going to be based off of like historical revenue data that the NFL can observe, right? I'm not aware of like a system where they are actually doing this right now. It's generally they're taking kind of whatever that revenue sharing is, which does try to take take its percentage base. So you are going to be getting a little bit more taken from the large market teams. But if you're truly going to try to optimize, you would want to try to target large and small market teams by exactly how much they were going to benefit from that number of ads. And then that would give you enough money to be able to target that optimal number of league-wide ads. Any questions there? So kind of introducing some stuff. There's some other stuff we'll talk about with leagues, and this will relate to future topics this week, which is we're going to hammer competitive balance. I know we looked at a paper last week that kind of showed, when you have more balanced games, so uncertain outcomes, we kind of generally think about that driving the demand curve up. So what are some things we can do to ensure that we have improved competitive balance or that we have more uncertain outcomes? So I'm not as well versed in this, so if I use the wrong terminology, someone can correct me. I probably should have refreshed my memory prior to class. But if we looked at European soccer, they actually have a unique way of dealing with this idea of competitive balance. So there's a lot of variation in the MLS. So we might want to think about like how could the MLS take a model like the European Soccer League and kind of apply it to their league, right? So different countries have different regulations. I don't even remember all of these, right? England banned paying club directors. Germany makes club officials personally guarantee their loans. There's different rules across these countries. Okay? And we've seen a pretty significant increase in recent years with the revenue they can generate, right? So one thing that they've done is create kind of this open league system where you can be demoted, right? So there's several leagues, right? And whether or not you're in, let me see if I remember any soccer fans in here. Premier League is the top one, and then it's Champions League. It always messes me up because like Champions just seems like it should be the top one, but it's Premier League is like the best league, and then you have the Champions League underneath it, right? Yeah.
Well, actually, the Champions League is like the best teams in Europe play, and then like the championship is the one that's under the Premier League.
Yeah, technically, there's the Champions League, and then there's the Champions.
So what's the league you get demoted to?
The championship.
Okay, my bad, not Champions League, Championship League, right? So you've got the Premier League, and if you perform poorly in that, you get demoted to the Championship League, correct? Okay, like I said, I know I always get these wrong. So, but the general idea that we're focused on there is you can get demoted, right? And why is this valuable to the league, right? Because if you have the low quality teams getting demoted, right, what are you guaranteeing is happening within the Premier League and within the Championship League?
Teams are always trying to get better.
They're always trying to get better, but also by moving them based off of their quality, you're getting games within those leagues that are more uncertain, right? I'm not getting the top team in the Premier League to play the worst team in the Championship League. So I'm kind of guaranteeing by this demotion system that I'm grouping these teams by quality and therefore getting up more. My product is always going to be more uncertain games, right? On top of it, this is actually something we'll talk about down the road, but it's an additional benefit of what? It can prevent tanking, right? There's this added incentive to stay in the top league because what happens if I stay in the Premier League? I can generate a lot more revenue, right? And so I can kind of add this incentive to keep teams constantly trying to you can imagine for our win model that we were doing, by adding in this additional thing where I could get demoted, what I've done is I've built some probabilities in there that like, if I don't hit a certain number of wins, my marginal revenue curve might be shifted way down, right? And so that adds this incentive for teams to kind of never tank during a season, right? Because there's huge cost to being demoted to the other league, or Championship League, right? So, we've got some pros and cons to this. I mentioned mainly the pros. The one con is, yes, there's an added incentive to win, but if there's an added incentive to win, that means that I'm more likely to move towards my win maximizing point, which means I'm increasing my expenses, driving down my profits, right? Which is fine if I do win a high number of games, like I'm targeting a high number of games, but in practice, I may not win all those games. And if I don't, well, now I've spent all this money, I've fallen, I guess I should change this, right? So now you have championship league, right? But now that I've, fallen to the championship league after I spent all this money to try to stay in the Premier League, well, now I can't generate as much revenue. I had paid all, had these huge costs, and now I get in something to a place where I don't have enough money to spend up to, get myself back up into the Premier League. So it's great in theory, like in terms of if we're talking about targeted wins, but because there's that added incentive to spend a lot of money, it can lead to these situations where if you get an injured player or something like that, it can kind of relegate you to that lower league for several years, right? Does that make any sense there? And this is just, we were talking about leagues kind of last week and when to finish up the discussion. This is something that's kind of unique to European soccer that we don't really see anywhere in professional sports. I actually was thinking about this the other day because I knew I was going to talk about this a little bit. But what's a league maybe that you could see is setting up a structure that they could actually do a similar thing?
They try with XFL a little bit.
So XFL is a little bit different in the sense that it wasn't owned by the NFL, right? But they've got the USFL now, right? Which is all under the NFL kind of umbrella. They have these venues, right? If they build it up enough, if they really wanted to, they could do something like starting to create some delegation, right? Where your low performing teams have the threat now of getting demoted to the USFL or spring football, whatever they want, as opposed to kind of the National Football League where revenues are going to be higher. Right? I'm not saying they'll ever get to that level, but I'm saying like that if that structure is there, you can see there could be some bonuses or some pros for trying to switch over to this system. I won't mention this too much because we don't have a lot of examples of it. But it's another way that leagues are trying to incentivize winning. So all of our major sports leagues are kind of thinking about like we had that choice between win and profit maximization. And you've got a certain number of each team faces their own different marginal revenue curve. That's what we would kind of think about as like a franchise, like each one of these teams is a franchise, as opposed to a single entity where whatever the league is, they're making kind of decisions for every single team in the league, right? So that would be more like a single entity league, right? Well, how can you guarantee this? Because owners will all then have to be forced to have a share of the league. Their revenues go straight to a middle pot, right? So like if I want to make sure that I'm maximizing my revenues, I have to maximize not my team revenues, but league-wide revenues, right? So now we all have kind of this common goal because we're all bought into the league, not bought into our specific team, right? So under this model, we're going to have these single entities. And I think the examples we have in the big league would be the WNBA and MLS kind of operate in this way. And this can help like young leagues because what might occur in younger leagues is that you have this disproportionate difference in market size. And if we wanted to find that, not just the population, but all the other things that we kind of mentioned, that early on, if you have these really certain games because you have a couple of elite squads and you also have some people who are very low quality, well, your league may never get rolling, right? So it really is important early on to guarantee that every single team is not trying to optimize their own outcomes, but optimize the league, right? Because the league isn't established yet. The revenue generating power from the MLS is nothing close to the revenue generating power of the NFL, right? So the MLS needs to be a lot more concerned about guaranteeing they can drive up demand with more uncertain games. Now the NFL cares as well, but right, just the league-wide generating revenue that's going to occur for them is going to be a much higher percent of their overall revenue. So we see this in early leagues, typically this single entity. Right? So I'll do a review quick because I kind of already did this. But then we want to go back to using some equations to think about the two monopoly markets we've already thought about, which are the ticket market and then also our win market. Right? So in general, we kind of have this whole model of a monopoly, right? Which is we've got our demand curve. They're the only producer, so marginal cost is our supply curve essentially. So we know that the socially efficient quantity is where supply hits our demand curve, right? Now, one firm's marginal cost are the only of the monopoly, right? So that marginal cost curve is our supply curve. So this would be kind of our perfectly competitive output. Right? From that perfectly competitive output, we could actually break this down to producer and consumer surplus. I don't have it on the slide, but I'll try to give you kind of in my hands, right? So we think about consumer surplus is going to be the difference between how much consumers benefit and how much it's costing them. So you can kind of think about it as we're adding up the difference for all consumers that are purchasing something in this market between their marginal benefit and the price that they're paying. So if we think about the perfectly competitive market, the price that would be set is right here, right? So consumer surplus would be the difference between the price they pay and the demand curve, because our demand curve is what's reflecting their marginal benefit, right? Producer surplus, everything gets flipped, where the benefit to the producer is the price that they're charging for their product, and their cost is wherever they're at on that marginal cost curve. So you can imagine for the perfectly competitive market, producer surplus would be the area below our price, but above our marginal cost or our supply. We then go to a monopolist. We know they don't make a decision. They don't choose the optimal quantity where demand hits marginal cost. They choose the optimal quantity where marginal revenue hits marginal cost. Marginal revenue is twice as steep. So we can see here, what does that result in? A lower quantity chosen by the monopolist. They go up to the demand curve to set the price. We've got a higher price, lower quantity. And what we can see is if producer surplus is the area below the price they pay, but above their supply curve, producer surplus actually increases. Consumer surplus, the area between the price they pay and their marginal benefit, the demand curve, has now decreased from this monopolist existing. And we have this new thing, which is deadweight loss. Deadweight loss is essentially any surplus that was lost by no longer selling a certain number of units, right? Or these units, between what the monopolist chose and the perfectly competitive market chose. Okay. So hopefully that's kind of a review. And if we had some equation, we could maybe calculate some of these areas, right? I kept everything linear. So we've got rectangles and triangles. So triangles, how would I calculate the area of a triangle? 1/2 times the base times the height, their length times height. Rectangles, obviously, length times width, or base times height, however you want to define this. Okay. So, kind of can think about, we get this higher price, right, from a monopolist relative to a perfectly competitive market. And we've already kind of discussed most of these firms, at the very least, have a local monopoly, right? So we know that they're going to be kind of exhibiting a lot of monopoly power. We also end up with a lower quantity. Now, this won't always be true, and we kind of look at this for some of the shifts that we might see for the ticket market, but that's because if we intersect at that capacity point, our quantity might not change, right? Because we can't sell more than capacity. Okay? I think I'll come back here because I want to kind of give, nope, I have these out of order. I want to do the ticket price one first. Then we'll come back to wins and think a little bit more about this. Okay. So I'm going to try to do this off the top of my head with some numbers. So let's say we've got quantity of tickets, price of tickets. Let's say I want 200. Kind of thinking about, here's my demand curve. 200 minus. I'm going to try to keep the math easy on myself today. Okay. So let's say this is my demand curve for tickets. Okay. I then know, okay, and this is going to be a little bit weird because we're talking about capacity, but bear with me. Just think about, maybe this is a very special type of seating, so we have a very low number available, right? Now, we could obviously scale these things up. I'm just going to get confused by the zeros, right? And turn doing my mental math. So we can think about whatever capacity is, right? I guess we could draw here capacity. Let's say I want this to be 5, right? For whatever reason, we have very special seating. There's 5 tickets available, right? Actually, it probably isn't the wildest model for some of the luxury seats, but So we've got this capacity, right? Well, now I drew this as though the demand curve is going to hit that supply curve. I don't really know that ahead of time. That was a little bit reckless of me, right? I know it's going to start at 200, but unless I'm very good at doing some quick math in my head, I don't know where this is going to hit my capacity curve, right? So what I'll first do is figure out, okay, I know they're not going to make this decision based off of demand. I know they're going to make this decision based off of marginal revenue. So I need to figure out where demand hits my capacity, if it hits my capacity curve, or if it hits my x-axis first. So that's the first thing I'll do. So how do I figure out where my demand curve hits my x-axis? Well, when it hits the x-axis, I know one of these things.
Zero.
The price is equal to 0, right? So I now have this equation where I can do a little bit of algebra. Divide this by 10. And I get what? Okay, so the demand curve is going to definitely hit way out here, right? It's going to hit at this quantity of 20, right? So I now know when I draw my demand curve, it's definitely going to cross that capacity of 5. But I don't really know that ahead of time until I figure out where that point's at. Well, that's great, but we know that we usually have these local monopolies in the ticket market. So the next thing I need to do is figure out what's my marginal revenue curve. So based off of what I have for my demand curve, what's my marginal revenue curve here? If it's linear demand, marginal revenue will be 10. So not where marginal revenue hits my x-axis. You're going way ahead of me, right? So I just want to know, what would that equation look like? So it's going to start at the same place, right? So I'm going to have the same intercept, but the slope will be twice as steep, or 2 times 10, 20, right? So now I've got this marginal revenue curve. I need to figure out, okay, does it hit my capacity or does it not? You already figured out, right? Where does it hit the x-axis? Well, that would be if it was at 0. So now I have this equation. Just have a little bit of algebra here. We can kind of figure out this would be an optimal quantity of 10, right? And generally, you think about if the slope is twice as steep, that x-axis point is always going to be kind of half that quantity, right? But this at least allows us to know that even my marginal revenue curve here is going to hit past that capacity. And that matters for if I then saw demand shifts, or if I'm thinking about, well, I need to know, what am I setting it equal to? And so I'll work through 2 different types of examples here. Okay. So everybody with me up to this point. It's a little reckless to just start drawing these because you don't really know if they're going to be hitting your capacity point or not. Now, from there, how can I figure out, I've got this drawn out, I don't really have to do a lot of work. What's the optimal quantity going to be here? If I know my marginal revenue curve is hitting that capacity, what's the optimal quantity? 5, right? I can only sell to capacity, right? So I've got this optimal quantity just by figuring out where those intercepts are for my marginal revenue curve. I automatically know my optimal quantity will just be what capacity is. Now, if it's not, it gets a little bit different, and we'll talk about the here in the next example I show you. So I know the optimal quantity is 5. What would be my what would be my monopoly price? What do? I look at that quantity. I go up to my demand curve because I know that's the marginal benefit of the last ticket purchase or last consumer. And so I can charge them up to that point. So we get this optimal quantities at capacity, and my optimal price will be wherever I'm at on that demand curve at the quantity of 5. So using my equations, what do? So remember, this is my demand curve. I'm sucking myself a little bit more here. So this is my demand curve. I can also think about it as my demand curve is telling me the marginal benefit of different quantities. So if I know that my optimal quantity is 5, how do I figure out the marginal benefit of that 5th unit? Just plug in my quantity of 5, right? So what? 200 minus 10 times 5 should be, I'm doing this in my head correct, 150. Right? Am I doing this in my head correct? Yeah. Okay. Any questions on that? So, I'm not going to push you any further than these linear demands. It gets a little bit tricky though, because if you don't know where they're going to intersect your capacity or the x-axis, you can come up with you don't know what to set it equal to. Here, because I knew it hit that capacity, I could use that optimal quantity of 5 to figure out the price that I could charge. Right? I'll show you an example where, what if it did? Right? So if everybody got this written down, can I erase this? We need a little bit longer. We're okay with it? So let's keep, let's keep everything the same. And I'll kind of remind you what we had, right? So let's keep our demand curve the same, right? And let's keep our, obviously if we keep that the same, we'll have marginal revenue be the same as well. We said these intersection points were 10 and 20, right? We already figured that out. So instead of putting capacity first and then figuring out where to draw your demand and marginal revenue, we could just start out drawing our demand and marginal revenue curve and then plotting capacity against that. So here's a situation. What if instead, I don't know, these are luxury seats. I realize that there's a high demand for them. And instead of 5, I increase it. So I've got 15 of them, right? So I've got a higher capacity, even facing those same demand, or the same demand equation. I think it was 10Q, right? And then we had marginal revenue was the same intercept, but twice as steep, okay? So now I know visually when I plot these, that the point at which that marginal revenue hits my x-axis is not quite the capacity. So if I'm a monopolist, what's my optimal quantity going to be? Where will marginal cost hit marginal revenue? Remember, until we hit capacity, I really have this marginal cost running along the x-axis. So I could set marginal revenue equal to 0 and figure out what that quantity is, but we already did, right? Inherently finding where marginal revenue hits the x-axis, that's telling you, well, this is the quantity if capacity is greater than that, right? Any capacity more than 10, given this demand equation, the optimal quantity would just be where that marginal revenue curve hits the x-axis. Right? And then from there, I want to charge the monopoly price wherever I'm at that quantity up on my demand curve. How do I find that? Well, I've got my demand curve. I'm just going to plug in my new optimal quantity of 10, right? So here I get what? 10 times 10 is 100. So now I see with a greater capacity, like this team would choose to sell a higher optimal number of tickets and a lower price. Right? But it kind of, it matters whether or not our demand and marginal revenue curve are hitting capacity or not in terms of what that optimal quantity would be. But it's always going to be one of those two things. I draw wherever you want these two curves to be. You're always either going to find the optimal quantity if marginal revenue hits before capacity. It's wherever marginal revenue hits the x-axis. If marginal revenue hits the x-axis past your capacity, or it's going to cross over, well, then you always know the optimal quantity will be whatever capacity is. Okay. Any questions on that, or what if something changes, or what else could we throw in here? Right with this? Okay. So we could do a very similar thing with the wins market, right? It's going to operate a little bit differently. We're still going to have a demand and marginal revenue curve. It's just that when we're looking at the wins market, instead of the quantity of tickets on our x-axis, we had wins, right? And we're no longer kind of stuck with capacity. But what I did do is I kept marginal cost constant, right? So what that would look like is kind of a similar more to the league-wide advertisement to a degree. So we can kind of think about, we've got some demand curve, we've got some marginal revenue curve. Let's just keep using the same equations as long as we can kind of keep the math kind of easy, right? So we've got my marginal revenue, and actually I should probably not say Q, I should say number of wins here. Okay. So we're going to keep using the same ones. Obviously, this wouldn't make as much sense in the win market, but we're just going to use the numbers to, so we don't have to switch everything up. So if we had a win market and here was our kind of demand and marginal revenue curves, how can we find profit and win maximizing quantities? Well, we said we had this constant marginal cost, right? And I could complicate it further if I gave you like just, some linearly increasing marginal cost, but for the sake of examples, I'll give you where you solve with equations. I'll just keep marginal cost constant, right? Simplifying assumption. Just makes the math more difficult if I give you a different equation. Right? So here, let's say I had a marginal cost of, what was going to work for me here? I don't know, let's say 5, right? How could I find my profit maximizing number of wins? Where is that going to be at on my graph? Yeah, where does marginal revenue hit marginal cost, right? We're maximizing profits. That's what we do in any market. So how do I find that point? Well, I've got my marginal revenue curve, right? It's twice as steep as demand. My marginal cost curve is just this constant value of 5. So I just set that equal to that constant marginal cost of 5. Now it's just a little bit of algebra, and I didn't make it easy on myself. So this is going to be what? 195 over 20. So something just below what would be 9.5? No, not over 20. Sorry. 20 over 195. All right. So it's going to be what? Anybody help me out with the calculator here real quick?
It's 195 over 20.
Wait, what am I looking at? Oh, yeah. Sorry, I had it right the first time. Sometimes I look at things on the side. It's all right. What's 195 over 20?
9.75.
9.75. I think my mental math's off a little bit there. So, all right, we can find this profit maximizing quantity. From there, how do I find the profit? I mean, we usually don't think about the price that we're setting, but if you want to think about the dollar amount associated with that number of wins, what would I do? Simply take that quantity and plug it into my demand curve. Right? But what if we wanted to identify our win maximizing number of wins? Well, there, the only difference is I'm setting the demand curve equal to my marginal cost. So I go up to my demand curve, 200 minus 10 times W equal to 5. 195 is equal to 10W. 195 over 10. I get 19.5. Right? So here, the win maximizing quantity or the win maximizing number of wins is going to be significantly higher. Okay. Any questions on that? So if I keep my marginal cost constant, it might be a little bit more difficult to see with these numbers. But what's always going to be true, we've got these linear demand curves as I've got my profit and win maximizing number of wins. So my win maximizing number of wins is twice as high as my profit maximizing volume. And that's just a byproduct of having this twice as steep marginal revenue curve. Okay. So as it's going good check if you have to solve for both of these to make sure that your win maximizing point will be twice as high. Right? Now, if we have different shaped demand curves, all bets are off. But for these linear demand curves, we know that should be the case. Okay. Any other questions on this? So when it comes to revenue sharing, I won't make you solve those models with equations. Those are the ones I just expect you to know that we did have revenue sharing. We kind of, how do we analyze those effects? We said we saw decreases in demand and margin revenue. We have this new average total revenue curve in. I'm never going to make you kind of solve through with equations and average total revenue model with revenue sharing. So that should cover that. What else did I want to say here? This is just more of a general statement. If you think about like the ticket market, and we said, well, we know they're going to sell a lower number of tickets at a higher price. How much money would they pay to keep that monopoly power, right? So let's, for the sake of this example, think about they've got a local monopoly, and they're thinking about, there's another firm who's trying to come in and in order to build a team, they need to get some support from the town and to raise taxes and raise enough money. How much money would they spend to go against that bond proposal, right? right? So how much money would they pay to keep that other team from being able to generate the revenue from the city to then locate in their city, taking away their monopoly power? Well, basically, whatever profits I'm earning as a monopolist versus whatever profits I can earn on a perfectly competitive market, which in the long run, that second thing should just be, in the long run, what is a perfectly competitive? Zero, right? So in the long run, yeah, it is the difference between these two, but it's always subtracting zero. It's essentially, I'll pay up to whatever the profit amount I can make as a monopolist is, right? Now, probably more realistic, you know, even if another firm or another team joins, it's not going to be a perfectly competitive market. It's probably going to be monopolistically competitive. So there in practice, we're probably thinking about they pay up to whatever that difference is, right? Instead of perfectly competitive, we might throw in monopolistically competitive. But you never know. I think, I haven't necessarily seen all the data, but if we have years of data and we equate the quality of the, control for the quality of the teams, something like LA, where you don't have two historically, what word am I looking for? Like teams who have been around in that area for a long time, you may very well see something that looks more perfectly competitive, right, in the long run. But the idea is here, they'll pay up to whatever amount of profits they can make as a monopolist. All right, so we went through those markets. What else do I want to say? Oh, this is another good point that relates to what you're talking about. So why might, I think I already have the answer up here, but we can think of some other ones as well. So sometimes there's been a couple publications that have looked at or tried to estimate where teams are at on their marginal revenue curve. We said even if their profit max, so let's assume that they even can drive marginal revenue to be kind of negative, right? Where they're targeting a number of wins that's past the point where profits are zero. They're actually eating into their own profits, right? So they're going past this point where marginal revenue is zero, and they're actually getting a negative marginal revenue, right? So they're negative profits. How might they be able to do that, right? Well, I talked about this a little bit, but like if they own a product that they believe is tied to the team that would then benefit, I'm okay taking a loss from my team, right? Operating at that negative marginal revenue point, as long as I can make up for it, making more money in my other product market, right? So if we have owners who have products that are linked to their team, in the data, we might actually see some negative profit values, right? And that they're operating on that kind of negative portion of the marginal revenue curve. Okay. Other questions on that? Okay. What else do I want to say here? We only got a couple minutes left. So I'll introduce this idea, and then we'll go through some very specific types of price discrimination. So we're going to kind of go back to the ticket market and look at that model a lot. And we're going to think about, okay, we know how the traditional monopolist operates under this model. Right? We know how to kind of work through that. But what could be the case is that we don't have to just charge a single price. All of our monopolist models that I've worked through up to this point assume that they're only setting like racing now, but they're setting one price for tickets, right? So what could they do? Well, they could try to charge different consumers different prices, right? And what would they want to do to optimize profits? Well, try to be able to charge consumers exactly what their marginal benefit is, right? So we've got a couple different ways of at least moving towards that direction. In practice, we're never truly going to be able to perfectly charge them what their marginal benefit is, but we can start to identify based off of different characteristics, consumers who might be willing to pay more or less for a ticket, or basically have a different demand. Okay? So kind of the examples we see of this, you see them segment groups into things like student tickets, right? Because they know lower disposable income, lower demand curves. I'm not going to be able to sell tickets to students at the same price as I can to the general public, right? And then these are like outside of sport, like early bird specials, happy hour, like restaurants, because I guess what they assume is that demand to drink at 3 p.m. during on a weekday isn't as high as 11 o'clock on a Friday night. Right. But I've noticed a lot of teams will do this as well. It doesn't happen as much at the professional level, but like you look at minor league sports, they play weekday games. Like some of the specials they run just to try to get people to come out to the game are like ridiculous. Like they do like $1 Mondays where like hot dogs are $1 or every, I know this, what are they now? The South Bend Cubs. They ran this special for a while where it was like dollar draft night. And it turned into an absolute nightmare for reasons why you can imagine. But like the whole point was like they needed something to try to convince people to come out to the game, purchase a ticket, pay for parking, and they don't care if they lose money, right? On some of the concessions, they're making up for it in revenue from other sources. So we'll talk about different ways that they try to price discriminate, different pricing strategies to try to kind of maximize profits on Wednesday. All right.